Hi, I'm Milan Gandhi. We have developed market elasticity analysis tool. This is the exe file that is executable. We'll just open it. It will take a couple of seconds to activate. So this is the tool, and which consists of two applications: S-curve analysis and price elasticity analysis. S-curve analysis is the S-curve model for analyzing the market share based on the frequency, the daily frequency of the flights, and comparing it with the two airlines. We can compare it with two airlines or number of airlines, and we'll come to know what is the market share of each airlines for that particular route. And price elasticity analysis is the application where prices, that is fares, would determine what sort of a demand would be generated. So first we will look at the S-curve analysis application. Airlines compete for the passengers and market share based on the frequency of services and departure schedules on flying on the each routes served. Price charge relative to other airlines, quality of service and the products offered at the airport and in-flight services. Passengers choose the flight schedules, prices and product quality to minimize the air travel disutility. Given the estimate of the total demand for the air travel in ODI market is the origin to destination market. What is each airline's market share? That is the key to this application. Several modeling approaches can be used to estimate airline market shares. The S-curve model, which we will be uh, using it, and there are other models also, that is extensions to quality service index, that is a QSI model. Then there is a logic model used in profit estimation software, profit estimation software systems. Now let's have this application with an example S-curve analysis. Click on this. Let's assume there are two airlines offering daily flights, assuming prices and service qualities are equal. So this is an example we'll take. This is market, means the city pairs, you can say. The itinerary is the schedule which is published by an airline. Segment is the route which they are going to fly. Airline, well, we'll compare two airlines, airline 1 and airline 2, to analyze what are their market shares based on the frequency of flights they provide daily. Then there is seat, that is aircraft capacity carrying this particular passengers for this route. The numbers of actual passengers boarding this flight. If there is a connecting route, so it could be connecting passengers. Number of passenger traffic would be the total of all this passengers and connecting passengers. Percentage connecting number of what would be the percentage of the connecting passengers. The load factor is load factor would be the seats available for this particular flight and actual number of passengers traveling. That becomes the load factor. And what is the daily frequency of the particular of this airline's flight, means number of daily flights for this particular. Based on this we can analyze the market share. So this is the first we'll take a route is IAT, and IAT is Washington to Boston. Itinerary becomes the same, which the airline will provide. this is the route we are flying, same Washington to Boston. We are using, this is airline 1. We're taking 2 airlines for this example. Then the number of seats for this particular route is the airline is providing is say 200 seats. A flight which consists of aircraft which has 200 seats. Then the numbers which have been boarded are 140. This is a direct flight from Washington to Boston, so connecting passengers are not applicable. The traffic is 140 number of passengers flying. The percentage of connecting is not applicable, and the load factor becomes it's calculated as 70%. So basically, if you look at it, 200 seats are available in the aircraft, 140 passengers are boarding the flight, so it becomes a 70%. And the number of flights flying for this particular route for this particular airline is 3 daily flights. The frequencies, that is. Now we click on the new row, and we will be having same route, but this will be having a connecting flight which will go from Washington to JFK, that is New York, to Boston. So this is the segment leg will be from, we will what we'll do is it's JFK, so this will go to JF, rather than that we'll go for Philadelphia. So this route would be this network would be from Boston, from Washington to Philadelphia, and Philadelphia to Boston. And the first leg would be the first segment, that is, it will fly from Washington to Philadelphia. This is airline 1. Now the number of the capacity, the aircraft which is provided is having number of seats is 150, and the passengers boarding on this is 125, and the connecting passengers are 75. That would be from the Philadelphia to Boston, and the traffic here in this particular route is 50% of connecting passengers is 75. The load factor is 0.83, which is calculated based on the available seats and the passengers boarding it. And let's assume this as 5 flights per day daily frequency for this route. Now we got to complete the network, so we'll same. So this is the same thing. Then this is where from Philadelphia to Boston it will travel, this particular flight. And yeah, it has to be 1. So this is airline 1. We'll complete the network. Now for this particular aircraft is having 150 seats capacity, and this will be having no connections because that's the destination. Boston is taken. So 75 is the number of passengers boarding. This is not applicable because this is not a connecting flight. and number of passenger traffic would be the same as the number of passengers boarding. This is not applicable. The load factor is 50%. Out of 150, 75% or 75 boarded the flight, and number of frequency, daily frequency for this route is 5. So this is done, and now we'll go to another route. Now we'll take JFK, that is New York. So from Washington to JFK to Boston. So first it will be, the first flight would be from this segment would be Washington to JFK. Airline, this is Airline 2. We are comparing Airline 1 and 2 for the market share based on the schedule, the daily frequency they are flying the same routes. And the Airline 2 is providing an aircraft of which is having the capacity of 250. At the same time, the number of passengers are boarding is 200. Connecting passengers becomes 100, because from JFK to we will go to Boston. Then the traffic would be for this route would be 100 from Washington to New York, and the percentage of connecting is 50%. 100, so it becomes 15. The load factor for this particular flight is 80, and the frequency here is 7 daily flights for this route for Airline 2 using this route. So we'll complete the network now that it has flown from Washington to New York. Now from JFK, from New York to Boston, that is the second leg of this particular network. This is Airline 2 operating. For this route, the Airline 2 has 150 capacity aircraft, and the number of passengers is 100. It's not connecting because it is reaching the destination Boston. So the 100 is the number of traffic, not applicable, and the percentage becomes 0.67 for this particular occupancy rate of this flight, and the number of flights, daily flights flying for this particular airline is 7. Now we'll have another route, Washington to Boston, Washington to Boston, Washington to Boston, but this is Airline 2 is flying. And it's got a aircraft which is having 100 seat occupancy of this is, number of passengers is 80. This is not applicable because it's a single route, one way single route, and this is 80, the number of passengers traffic. This is not applicable because it's not connecting. Load factor becomes 80. Number of flights flying daily is say 2, the daily frequency for this route for Airline 2. Now we'll add another market in this, that is from Washington to Petersburg. So it will go from Washington to Boston and Boston to Petersburg. And the first segment leg would be, the route would be from Washington to Boston. The second one will be from Boston to Petersburg. This is Airline 2. The seats available for this particular route is 200. The aircraft capacity is 200. Number of passengers boarding is 150. So there is a 75 number of passengers are going to be connecting, that is from Boston to Petersburg. That would be the destination. And say that, so the traffic for this particular route is 75, and percentage of connecting passenger is 50. The load factor is 75% for this aircraft, for this capacity, and the numbers of seats occupied, and the frequency is 4 daily flights. So for this route, network route, again we'll have to complete the network. So same thing here, but now the route would be from Boston to Petersburg. To complete the network, Airline 2 is operating, and the aircraft available, which has got a capacity of 150, and number of passengers traveling is 75. Is not applicable, connecting is not, because we are reaching the final destination. And personal traffic is 75, and so this is the 50% of connecting. Sorry, this is not the 50%, we're just having not applicable, because this ending the flight 75 and the traffic is 75. The 50% of occupancy, the load factor, and the number of daily flights would be 4. Now this is what we will compare the two airlines flying the same route, and we have assumed them having the same airfares and the schedules which are provided. Based on the schedules, we'll take a route which we will analyze. Let's take this route as from Washington to Boston for Airline 1. Okay, so what we'll do, we'll highlight that, and we'll take this, and then we'll have the same route for Airline 2, who is also flying the same route. We'll highlight that also, and we will highlight same thing, Washington to Boston, Airline 2. So 2 flights for Airline 2 and 1 flight for Airline 1. So we'll highlight this, and we'll see the calculation how which will give us the market share, the frequency share, some of the segment supply for the the number of seats were provided for this route for both the airlines. We'll compare them and see finally the report. So we'll save this report in the same place where we started the exe, and name this as a market share. So we'll save this. Yeah, the market share XLS file is saved, and we'll see the report. So this is the report being generated where you can see the data which we had input till here, and we can see the other columns which is automatically generated. The frequency share for this route was 3, for this route was 2 and 4 for airline 2. For airline 1 we are talking about Washington to Boston frequency share. Then the market share is this. It is already calculated. The market, that is ODI from Washington, we have taken from we are analyzing the market for Washington to Boston. So that is that figures. Segment supply means the aircrafts which were supplied to carry the passengers. The number of total capacity of the aircrafts is here. For airline 1 for this route was 600, 3 flights a day with capacity of 200 seats. So that becomes 600, and the same for airline 2, which had a frequency of 2 aircrafts having capacity of 100, so that is 200, and the other one is 150 capacity having daily flights of 4, so that becomes 800. That is calculated. RPM is revenue per mile of a passenger of the passengers, what revenue is generated per mile. And the available seats, ASM is available seats mile, which was provided by the airline to carry the number of passengers, so that is calculated. This is average load factor, of averaging the load factor for this route for the 2 airlines. This is one average load factor was 2.1, and for airline 2 it was airline 2 it is 1.6 and 3. Okay, we are calculating this airline 2. So an overall average load factor is this and this, and this is the total of RPM, this is the total of ASM, and that becomes the network load factor. This becomes the network load factor, that is for based on RPM and ACM. So this calculations is done, then we'll get the final one here for airline 1 and airline 2. Airline 1 had 3 daily flights, frequency was 3. So here airline 2 was 6, because this 4 plus 2 6, the sum of frequencies or daily frequencies. And then the market, sum of the market share, the number of passengers who had flown from here. This is the one, this is the one from where you can calculate this. Okay, this is the one, and the total number of passengers carried out, that's a market share for both the airlines in totality. The number of seats which were provided, so this is 600 and this is 1000, that is 800 plus 200. So this was the number of seats supplied, this of the number of passengers flown for this route, and this frequency, the total frequency of including both the airlines was 9. So what is the share, market share for this based on the frequency? The frequency is 33%, and some of the frequencies for airline 2 is 66%. What is the market share? This is what the answer is. The 40% of the market share goes to the airline 1 flying the route of Washington to Boston, and 60% of the share, percentage of the share is for the airline 2 flying the same route with this particular frequency, that is this number of 6 daily flights. And sum of segment supplies, the number of seats were provided by airline. Comparing airline 1 and 2 is almost 37% for airline 1 and 62% for the airline 2, in totality 100%. So we compared 2 airlines, and this is the report in generated. This is the report generated time. So this is the first application which gives the market share comparing two airlines. Now we go back to the application and go home. We'll go for the second application, that is price elasticity of elasticity analysis. This is basically called as the price elasticity of demand. So if there is a percentage change in the total demand occurs within the 1% increase in an average price charge. The basic idea is that the airline market strategy must account for the sensitivity of the passengers' demand to airfare frequency, that is also called as the displacement time, and the service quality. If passengers are sensitive to these properties, they are called as elastic. Then decreasing fares, increasing frequency, and improving service quality can result in increased revenue. They are basically for the leisure travelers who are price sensitive, who are going on vacation. Conversely, if the passengers are not sensitive to the properties, that is, they are called as inelastic, then increasing airfares, decreasing frequency, and reducing service quality can result in reduced operational cost with impacting revenue. They are basically the business travelers who don't mind paying more fare, as for them the reaching on time is important. So there is a formula basically for this market plus demand is equal to market plus market means origin destination market, 2 city pairs you can say, plus fare plus the time. Here the market and time are always constant, in a sense. The market of say from which we took from Washington to Boston, it is constant. The time to travel is constant. So the formula actually becomes for demand is constant plus fare. Basically, business travel demand is inelastic, means they are less sensitive to the prices, they are willing to pay more price but want to reach on time. Whereas the leisure travel demand is elastic, means they are very sensitive towards the increase in fare prices. So this is the application. And there are also other elasticity called quality elasticity, and there is a time elasticity, and this is what we are looking at, is the price elasticity. So let's start this. This is new. Let's take a fare. We are taking an example where a leisure passengers who are traveling on a vacation or a personal for a personal reasons. So we'll take this particular route of Washington. Basically, it's a DCA market. First, let's enter the fare for this particular market is, that is origin to destination, $85, and the number of passengers is 363, and the market is say DCA. DCA is a Washington area market. So within that area, there could be there is whatever the city pairs you can travel. So this is the market. So this is the fare, number of passenger this is the fare. For this fare, the number of passengers are 363. The demand is 363. Now we'll take another one. Say increase it by $5 and make it $90. Then the demand for is 99, and it's DCA. These are the calculations, the internal calculations happening within. So we'll be getting a particular prediction where we'll get a figure which would be, we would convert, we would look at it as a percentage. So DCA market, same market we're traveling. So fares increased by another $5.95. The demand for it is 93. The market is same. Let's make it 100. So for $100, there is a demand is 32 passengers. 105. 19 passengers, or demand is 19. 110. 22 number of passengers, demand is, if the price is 115, the demand is 8 passengers. If 12 passengers, the demand for $120 ticket fare is, if it is 125, demand is 13 passengers. If it is 130, then the demand is 13 passengers. If the fare is 135, the demand is 8 passengers. $140 fare is, the fare is for 140, the demand is 14 passengers in the same market. Now let's say how the demand, what does this particular demand suggest? Let's click on the predict button, and we're getting the prediction 6.3. The negative, always price elasticity is negative. So what it suggests, it says if for every increase of 1% in the fare, 6% decrease in demand. So this is a leisure market we have taken for the leisure passengers. So they are price sensitive. The fares increases. If the fare increases, the demand decreases. As you can see, the demand was 363 and it is dropping as the fare increases. So what this particular tool does is to estimate what would be the demand levels if the price is increased for the leisure prices. Same way we can do it for the business travelers, where we can see if the price increases, does the demand drop, or if it drops also it would be marginal. But here the drop is higher because these travelers who are going on a personal visit or for vacation are very price sensitive to the fares. So what a particular airline can do is to predict this particular scenario, and based on this sort of prediction, fares can be finalized. We can also generate a report from this same place where we saved that the file. As Elasticity, so we'll save that. You see the report also. So this is the price elasticity report. We'll open this. So this is the report. The same thing has been generated here. Passengers, number of passengers, market, same. This is the internal calculation which gives the prediction, and this is the report generate time. So this tool helps the airline to estimate, finally provide the fares to the passengers and differentiate between the business travelers and the leisure market. This one was for the leisure passengers. The same way can be done for the prediction, can be done for the business travelers also. So this is the tool which we have developed, and which could be very handy to the airline to analyze the market share as well as the price elasticity of demand. Thanks for watching it.